My name is Terry Johnson. I am a teaching professor in the bioengineering department. I have been here since 2001. I'm the vice chair of undergraduate instruction. So I want to give you an idea of what the department is like and give you an opportunity to answer some questions. So I see some folks appearing. That's great. Thank you. Like I said, anybody wants to jump in, that's fantastic. So who are we? So we have about 26 faculty. I'd say we're a medium-sized department. Some of those people are split between multiple departments. We're approaching 500 undergraduates. I don't think we're there quite yet, but it is happening very soon. Approximately 100 master's students and around 180 PhD students. We are part of the #2 public university in the world, the #7 undergraduate bioengineering program, and the #4 PhD program. And we talk about the PhD program because you will have an opportunity to work with students in that PhD program. Our other programs, so we have the undergraduate program. We also have a joint program with UCSF, and that is our PhD program. So the PhD program is actually joint. It's a combination of an engineering school, college and a medical school, UCSF. Through the Fung Institute, we and the other engineering departments offer a Master's of Engineering in Bioengineering. And we also have a Master's in Translational Medicine, which is also joint with UCSF. And that is a specific master's focused on taking new technologies and transferring them from the bench to bedside. So basically taking technologies and moving them from a research project to a product. We have a variety of undergraduate concentrations, and these reflect the expertise that we have in the department. If you've been looking at different universities, and I hope you have, you'll note that they all do things slightly differently. We share most things, but we do focus on specific areas, and those are different from university to university. Here, we have cell and tissue engineering, and this is the most popular choice for our pre-meds. We have a pretty significant pre-med population in the university. We are the department that sends the third most students to medical school after molecular and cell biology and integrative biology. You don't have to take this concentration to go to medical school. It just happens to have a pretty good overlap of interest. Biomedical devices, and this is leans heavily towards diagnostics, and we'll refer to that a little bit later on. Synthetic and computational biology, where we have a focus on basically using microbes and basically using engineered microbes to make things like pharmaceuticals or commodity chemicals. And biomedical imaging, things like X-ray, MRI, and next generation technologies that allow us to see what is wrong with you without having to open you up. We also have a joint degree in biomaterials with MSc, so material science and engineering, which is relatively small, but a number of students that are very particularly interested in biomaterials, particularly polymeric biomaterials, often are interested in moving to the joint major. And we have people from bioengineering going to the joint, and also from MSc going over to the joint. There are a variety of classes that will sort of help you make this choice. BioE 10, 26, and 25, not in numerical order, but in the order in which you would take them. BioE 10 is an introduction basically to engineering design in the context of bioengineering, and it also talks about devices in those concentrations. I can say that safely because I teach that one. 26 is a seminar course where you learn about academic bioengineering, and 25 is a seminar course in the next semester where you learn about industrial bioengineering by hearing about careers in bioengineering and research in bioengineering. By the way, I see questions coming up. If you have a question as we're going, just type it into the chat and I will hit it at the end. So at any point, feel free to jump into the chat with questions. What does our curriculum look like? In the first semester, you're going to take BioE 10, typically math and your Gen Chem courses. In the second, you add on physics. You take your first semester of organic. In your third, typically a programming course along with physics and math. And then you start to diverge a little bit. You notice I'm only saying there are 3 courses there. You'd be taking humanity courses as well. But in the 4th semester, you finish off your math, you've got your physics, you've got your programming. You take BioE 11, which is engineering molecules 1. And that is, how do you look at biology from a ground up engineering point of view? You follow that with a fundamental, which is a course that you choose depending on what concentration that you've chosen, and engineering molecules 2, where you start looking at collective behavior of the types of molecules that you're engineering. This is sort of thermodynamics and a variety of other things that sort of help you figure out how would many molecules act together in terms of design. And then you could take another fundamental and take engineering cells. So you're building up, starting from molecules to collections, molecules to cells. But you may take an entirely different route. You may instead be focused on devices, electromechanical devices. So you would start by taking BioE 105, which is engineering devices 1, followed by BioE 101, which is the 2nd semester of engineering devices. So the idea is that you share many of your courses for your first 4 semesters. Those are chemistry and physics and math. And then you diverge by starting to move in a particular direction. Are you going to be more on the sort of cellular chemistry end of things, or the more physics and mechanical end of things? Then you will start taking fundamentals courses in those subfields based on the published concentrations, which will tell you what kind of classes and what order you want to take. So here's our faculty. I think I got them all. They work in a variety of different fields. Most of them you can probably map to one of those concentrations, though many of them work in several. Here are our joint faculty in other departments, our emeritus faculty, our teaching faculty, of which I am one, and our adjunct and affiliated faculty, people that come in from industry, for example, interested in teaching 1 course a year and reaching out to students from a very practical point of view. So what do? They do a bunch of stuff. I couldn't possibly cover the work of all of our faculty in even a long talk, but to give you an idea, in a year, they spend around $35 million on their research. And this is slightly older, so that number has likely gone up. They have, at the time that we did this a couple of years ago, 72 active patents and 23 licensed patents. Patent numbers can be a little confusing because there's lots of patents out there, but in the field of bioengineering, they're not typically vanity patents. To have 72 patents, 23 of which are actually generating money, gives you an idea. The average amount of money that a patent earns, or I should say the median amount of money that a patent earns, is 0. Most patents are never licensed. Bioengineering, 72 is not bad. 23 out of 72 is fantastic. Published by core faculty since 2008, over 1,000 peer-reviewed papers, well over 100 a year. So it's a very active department in terms of its research. Our staff have over 150 years of experience just in the UC alone. 2 outstanding staff awards, Campus Excellent in Management, 4 Staff Achievement Awards, and a variety of spot awards. I need to update that because I know that it's more than 5 now. But we have staff that really know the curriculum, the campus, and the faculty very, very well. And we really appreciate that support. Maricela, if there's anything that you want to say, Maricela is our undergraduate affairs officer. So of our staff, she is the person that you would have the most contact with.
Sure. Hi, everybody. I'm Maricela. It's a pleasure to meet you guys virtually. I look forward to working with you a little bit more closely as we basically start the next 4 years of your lives and a very important times in your lives as well. Best way to reach me is via email, which is already on that slide. And then the special Cal Week drop-in advising, I've dedicated just 1 hour each day for the rest of the week to you. If you find yourself having any random questions, I just want to run this past her, get her ideas. How do I do this? Feel free to pop into those office hours. Don't worry too much about writing that down because it's also on our Cal Day website. And that's basically it. I don't want to inundate you with too much information, but just wanted to say hi and welcome.
So what do? Long-term plans have not changed very often. This specific data is from 2017. Around a fifth of our graduating classes go to medicine. Around 12% are aiming for a faculty position, around half to biotech or medtech. And there is a balance, people that are going to law school, nonprofits, a variety of other things, or unsure. So this is a fairly typical slice of futures from the bioengineering department. And to get really specific and just to make us sound cool, I'm going to focus on some pretty fun stuff. So best paying industry, yeah, we're doing fine. You know what? It's not that important. You have an engineering degree of any kind, you're going to do fine. You're going to be okay. But you want to be working on things that motivate you. Like that is the most important thing. You want to choose an engineering degree that allows you to solve the kinds of problems that you want to see solved. I'm going to talk about bioengineering successes, and I'm a bioengineer, so I like these sorts of things, but don't be a snob. All the other engineering disciplines, they do fantastic work too. It's just not the kind of stuff that I would choose to do over the things that I can do in bioengineering, right? When I read those magazine articles that say, 30 under 30 engineers, right? Engineers changing the world. I have the opportunity to go, I know them. He's a faculty at UC Irvine. He's a co-founder of a therapeutics company. Top innovators under 35. I know them. She's the CEO of Zephyrus. She's the CEO of Dot Labs. In Emeryville, we have a variety of students that are working here. You see that 24. They have lab coats and they publish your employee number. So that is the 24th employee of Bolt Threads. They make spider silk using yeast. And they turn that spider silk into clothing. They've recently branched out, pun intended, into using mushrooms to make basically vegan leather. And they have just reached a deal with Adidas. So if you look online, you will be able to see their shoes where all of the leather is actually Milo, which is their brand of mushroom leather. And that is another graduate of the bioengineering department, the CTO of Bolt Threads. So all of these people are graduates of the bioengineering department. Some of you may have used or seen one of these. This is Lucira. It is the first FDA-approved COVID at-home test. And here are the two founders, as well as their head of engineering, all graduates of Berkeley BioE. This is a chart looking at infections of COVID in the local community, searching for variants. And this work was led by two faculty members, one of whom there at the bottom, Dr. Leroux, is faculty in our department. So, I mean, I'll be frank, but all the bioengineering, all the engineering departments, they all do cool stuff. This is the cool stuff that we do. I think it's pretty cool. And you'll have an opportunity to do this while you're here and to go off and do things like it after you graduate. This is the community. We're bioengineering, but we work with everybody. We work with UCSF, we work with institutes on campus, we work with people that have interesting equipment, we work with people that have interesting skill sets. We work with people on campus and off campus. And many of these are acronyms that you're unfamiliar with. A couple of them are acronyms that I'd have to look up, but these are all people that you would have an opportunity to interface with here at Berkeley. So thank you for listening. I'm going to take questions from the chat. So if you have them, please feel free to enter them. But that's us. And I hope that that is of interest to you. I'm going to go through these, and there are a number of them. So I'm going to kind of lightning round. Is it possible to double major in BME and MCD if I am an MCD major? It is possible. It is frankly difficult. I will put on my advisor hat for a moment as head of undergraduate advising. I'm not actually a huge fan of double majors. If you are interested in bioengineering, there's a minor, but just take our classes. They count for things in other majors as well. Do research with a bioengineering professor. Join the Biomedical Engineering Society. There's lots of ways that you can be part of bioengineering without necessarily getting a bioengineering degree. Double majors are great if you've got a ton of AP credit going in, but research, taking time to do research is going to be far more important for you in the long term. So possible but difficult, but there's lots of different avenues. How does the curriculum differ for transfer students? We waive a couple of requirements, and Maricela can go over that in a little bit of more detail, but you basically come straight in. You can contact us before you sign up for courses so that we can help you choose a concentration faster. But it's relatively similar. You know, it's not dramatically different. It basically just means you kind of hit the ground running, choosing a concentration usually before or during your first semester. Differences between Engineering 7 and CS 61A. One is MATLAB, one is Python. One is using software tools to do very powerful things, and one is learning to program. There's a lot of overlap between the two, but I would say the primary difference is different languages. What is the best way to get involved in research for this fall? Oh, this is the question I'm going to suggest don't, unless you are a transfer student. Don't try to get research your first semester. Learn to college. It is very difficult to get research your first year, but most students, the last time we looked at this, graduate with on average, over 4 semesters of research before they leave, including summers. So people do research. Some of it in the sophomore year, primarily in the junior and senior years. You are allowed to do research in your first year, certainly. We don't especially encourage it, just because it is easier to do after. Does the curriculum cover or touch upon anything related to, sorry, you're so fast, I'm losing track. I don't want to miss anybody. I did kind of cover BioE research opportunities. So yes, you know, lots of bioengineers do research. It is a requirement to do research or to be part of our design course to graduate. Does it cover or touch upon anything related to artificial intelligence? Sort of. Artificial intelligence is algorithms with good PR, and we do tons of algorithms. So there are courses in using machine learning, in managing data, biological data, in a variety of contexts. That'd be mostly in the synthetic and computational. Although students in that track may also take a couple of electives in electrical engineering and computer science and machine learning. How many students tend to pursue medical school? Around 1 in 5. Can you tell us more about synthetic and computational bio and what kind of things we would study? So you would study how cells perform chemistry, the math and physics on how cells perform chemistry, how computers are used both to drive the robotics that do a lot of synthetic biology and also to design proteins, to actually design molecules. And you would use that to make stuff, right? To convince and cajole via genetic engineering bacteria and yeast to make drugs or chemicals that people need. Would you be able to change your concentration or take classes for multiple concentrations? Yeah, absolutely. Many people do that. We just, you want to be careful using the concentrations as a guide so that you don't jump into a course that you don't have the prereqs for. But so long as you're careful and willing to put in the work, many people explore a little bit within the concentrations. Wondering how, I've heard it difficult. People say it could be difficult with a large student body to get research opportunities. Okay, so Berkeley is big. That is both a bug and a feature. It is a bug in that you will have to look for research, right? It is a feature in that there's lots of research. So the advantage here is you'll have to knock on some doors. You'll have to go to some office hours and talk to people to find the right fit for you. But because it is a big campus with many, many, many hundreds of labs in the natural sciences, there are many different opportunities that are probably exactly or near what you're looking for. So it is a search. But in many ways, that's advantageous. It's a difficult search because there's so many choices. Is it possible to study abroad as a BioE student? Yep. Usually you would come and talk to me about coming up with a plan for the courses that you would take at the university that you were visiting and how they would count for courses here. But we do that routinely. We have, I'd say, maybe 3 or 4 people a year doing that. Yeah. If you are looking to double major in EECS, would you recommend against that combo? It's a little bit easier to double major within another engineering major rather than MCB, which is outside of the College of Engineering. It's in letters and science. I wouldn't recommend against it. I think I would need to sit down and talk with you to sort of figure out exactly why that would be the right move for you. You will always hear from me, if it's the choice between getting a double major or taking some classes in another major and doing research while you're here, I'm always going to lean you toward the research, right? But it may be that you could do both. That's really kind of on a case-to-case basis. How do you select a concentration? BioE 10, BioE 25, and BioE 26 are going to expose you to lots of different work in the concentrations. So they'll really help you figure out what will work for you. What are the most popular, would you recommend following the first semester outline, or should we place out of those classes with AP credits? I think that placing out is not a problem, and then you just move to the next class. If you're ever nervous about placing out of a class, lots of materials available online. Look at what book they use, look at what homeworks they did, look at their exams. If you go, yeah, I got that, then go to the next class. If you're nervous about it, then talk to us. Popular minors for BioE students. Great question. I don't know that. EECS is fairly electrical engineering, computer science. We pronounce all acronyms at Berkeley. EECS is fairly common, but people do music, it's all over campus. It's fairly broad. Are there some job startups that students work at coming right out of undergrad? Yes, but they're all over the place. Bolt Threads, for example, takes on students from us. They're in Emeryville. There's a small biotech hub in Emeryville. There's biotech in San Francisco. There's a variety of places that people go. Do I know what percentage of BioE plus pre-meds get into med school at Berkeley? I don't have a percentage for you, but like I said, we're the third. We we are the department that sends the third largest per year number of students to med school on the Berkeley campus. And obviously MCB is number one. They're a very, very much bigger department than we are. Anecdotally, I would say that we're successful placing people into medical school. How can we know more about different concentrations? You can look online on our webpage. You can see short descriptions of the concentrations, and then it's a matter of looking at of taking those courses. Is there a list of classes which AP credits can be applied towards? There are, and I am not qualified to advise you, but I know that Math 1A, 1B, and Chem 1A, 1AL are on that list. What concentration should I choose if I'm aiming to study and develop nanorobots and biomems for the human body? Medical devices is probably number one, although nanorobots might lean into synthetic biology depending on your approach, but probably medical devices. What are some partner schools you can take courses at? We don't really have partner schools, but if you want to take a class at another institution, you can apply by petition to have that count for a course here. And that's how we do, for example, when students are doing study abroad. So it's not really that there's sort of like a small number of places and a list, but we can sort of ad hoc those together based on your interests. So if you have something you want to do like that, just you would come and talk with us. Do transfer students have to take the courses that introduce you to the concentrations? Oh, I'm sorry. How collaborative is BioE? Berkeley is rumored to be extremely competitive. We're collaborative. I don't know of any of the BioE classes where we have one of those weird curves that basically say, no matter how well you do, 20% of you are getting Ds. Like that's not something that is part of the bioengineering culture. And it's actually pretty rare across Berkeley. I know there's the Berkeley memes page. It doesn't feel like the life that I live. So I would just say people tend to work together. And if you're worried about that, talk to students at events. When do we need to choose our concentrations by? If you're a transfer student, end of your first semester. If you are coming in like end of your first year or maybe third semester, depending. Depends also on how much AP credit you come in with. Do transfer students have to take the courses that introduce you to the concentrations? I am forgetting whether transfer students are exempted from BioE 25 and 26. No, they're not. But those are 1 unit pass no pass courses. So they're not, they're useful and the workload is relatively small. Where will the recording of this session be posted? I don't know, but we'll get back to you. Music is probably the second most common minor from Pam. Thank you, Pam. More information about courses at Berkeley, like the textbook used or the tests given. Textbooks depend on the instructor, but you can very often search online to find out what's been used in previous semesters. Tests given, I'm not quite sure where you would go for that. Most of the courses have exams. Some replace those with final projects. Do more BioE students do research or internships? More than who? I will just say we do a lot. What percentage of BioE students complete minors, double majors, or simultaneous degrees? Double majors is a relatively small percentage. It's less than 10%, I'm almost certain. Minors, I don't know offhand. Are there a list of current students who we can talk to so we can learn more about different concentrations? I would suggest reaching out to BMES, the Biomedical Engineering Society, or BioEHS, the Bioengineering Honors Society, and Pam has a comment.
The panel on Wednesday afternoon, I put the information in the chat where some students are waiting to talk to you.
Perfect. Will BioE 10 be virtual this fall? It will be a virtual lecture. We will have some remote discussions and mostly in-person discussions. Do students do research with other departments frequently? Yeah, about half of bioengineers do at least some research with someone in another department. And we have people from outside of the bioengineering department doing research with us. I've actually had someone who I've worked with who then worked in Jennifer Doudna's lab, which is kind of a step down, but that is totally wrong. I just want to be very clear on that. Jennifer Doudna was the right move. You go. You take major related classes in the first or second year? Absolutely. Just depending on if you have the prerequisites. Are all the BioE classes in Stanley Hall? Nope, you're going to have a nice schlep around campus. They tend to be in the general area of Stanley Hall, like that side of campus, but many of your courses will be kind of distributed. What is the BioE policy on taking community college summer courses? If they count for your requirements, that's great. I don't think that we have a policy, yay or nay. Can you take major related classes at the same time as gen ed? Yeah, if you have the prereqs, that's the main thing. If you're prepared to take the course, you absolutely can. And if you're not sure about taking a course, just ask us. I think I caught up with it.
Well done.
Ooh. Luckily, as you can tell, I talk very fast.
Terry moonlights as an auctioneer.
Yeah, going once, going. Do you get an advisor to help us choose classes? You get advisors. So you will have an advisor in engineering student services. They're going to focus on, in many ways, the degree check, right? Which is does this class count for this? What do I need to do to finish? They're also, helpful in a variety of ways. Maricela is the in-department advisor. And she obviously can also help with the degree check, but can also be really focused on helping you, like, I want to study abroad courses. How would I do that? What is that process? She would be somebody that would coordinate that. And a variety of other tasks. Like I would say Maricela and I often, if ESS this is the regular path and they're going to describe it to you, Maricela and I are ones that help you find deviations from that path that are right for you. You'd also get a faculty advisor, which would be me in your first semester. And then you would often, once you've chosen a concentration, move to talk to a faculty advisor who specifically works in that area. When and how can we declare a simultaneous major? You kind of do that with the other major, right? If you're already a BioE, then you go to the other major and go, hey, I want to do this too. And they have their own process. Are there any BioE clubs? Are they easy to get into? I've heard it's sometimes hard to get accepted to clubs at Berkeley. Okay, there are some clubs that tend to be very small and very focused on things. But most of the clubs are large and very inclusive. The big ones for BioE: Bioengineering Honor Society, the Biomedical Engineering Society, Society of Women Engineers, BESA. I'm forgetting another, but there's Tau Beta Pi. There's a variety of engineering groups that are either bioengineering specific or pan engineering that are very active on campus. So I would say there's definitely plenty of people to talk to. How can we prepare over the summer for our first few classes in BioE? That's an interesting question. So I would say, first off, chill. It's been a year. It's been like a real year. right? Take some time to yourself. Don't feel like you need to overburden yourself on the way in. Figure out what your classes are going to be. Maybe do a little bit of Googling around that. But I really think you should spend some time preparing yourself for a major life change, right? And thinking not just about like what chemistry I need to stuff in my head, but how am I going to keep up with friends that I'm going to miss? You know, like what's my strategy for like keeping up with family? What are the things that I need in my life that I want to reproduce on this campus? What are clubs I want to try? Because you're gonna in your first year, you're gonna go through like 20 clubs and you might settle on 3 or 4, and that's perfectly fine. But what am I excited about? Like what's gonna get me out of bed? Let's see. Culture. What are the faculty like? They're pretty much human. So they're like, they're all very different. They all have very different interests. They all like to do very different things. They are all deeply engaged in research, and all of them have undergraduates participating in their labs to one extent or another. And I think Pam raised her hand.
I was just going to say that was me suggesting questions.
So you know, like the faculty you will get to know by taking their courses, by going to events, and you'll find we're a diverse crowd that like to do diverse things, right? We have you know, like faculty that build MRI machines. I teach a class on science fiction and biology, the history of, you know, science fiction and biology, because I'm a nerd, and everything in between. So are bioengineering students relatively relaxed? I mean, you're not going to be super relaxed. It's engineering. But I would say that you are not unnecessarily stressed. Our goal in the bioengineering department is not to punish you for choosing engineering. It is to challenge you, because we want you to leave and then do amazing things which reflect well on us. And that requires a certain level of preparation and attention and inspiration. So it is a challenging major, but it is not by design a punishing major. We want everybody to succeed in it. And it's like, or MCB students, for example, I'm not going to compare us to other departments, you know, like that's just not cool. Those are my colleagues. What are the most liked and least liked parts of the major and its programs? That's an interesting question. I think it depends on the student, right? And I would also say this, all of you are going to have a favorite class and all of you are going to have a least favorite class, and they're probably going to be very different, right? Just based on your interests. Look, I was not good at thermodynamics, right? That was not my favorite class in school. I really like kinetics. I taught thermodynamics a couple of years ago. It's fine, right? And I actually really enjoyed it. But you know, it's really going to depend on you. Do classes close due to maximum? Okay, so is it difficult to get into classes? I think is what that means. We reserve seats for bioengineers for our courses. What are the hardest classes? Depends on how much you want to learn in them. All of them have elements of that are difficult, right? And I think that's really a matter of how much you want to get out of it, right? Like I think that you can do well in my transport course, and have it be a challenging but not punishing course. And I think it'd be a really difficult course if that's one of the courses that you're really gung-ho about and want to drive through. And like, I want to move closer in this direction. I plan on using this next year. Does the BioE major ever have events outside of classes? We absolutely do. A variety of events connecting with alumni. So alumni come in, talk about their experience in their fields. We have opportunities to sort of connect people with potential internships. We bring speakers in on a regular basis. So yes, compared to other engineering departments, our students are, oh, sorry, that's not a question, that's Pam's comment. How easy is it to form bonds connections with professors? How large are the class sizes generally? Class size will shrink as you move on. So your first year courses will be very large, but your sections will be small. And you get to the senior year, like your fundamentals courses are going to be around 90 students, 60 to 90 students. So that's, sophomore, junior year. You get to the senior year courses, there'll be labs, which are, maybe in the 20s and 30s, and a variety of courses that are maybe in the 40s and 50s, with sections that might be smaller than that. Forming bonds and connections with professors. Here's how you do that over our shared interest, right? So you will form connections with professors by talking about the work. And when you find professors that are interested in the same stuff that you're interested in, you will form bonds. That's where you'll have research relationships. If you take a synthetic biology class and you decide that you're really more of a biomedical devices person, you'll probably have more of a connection with the biomedical devices people because you're sharing the work. That's the thing that's bringing you together. But you have plenty of opportunities to do that while you're here. Yeah, go to office hours. I'm actually paused. Go to office hours, work with other people. Second advice, work with other people. Third advice, work with other people, right? The failure mode for your first year, like here, I'm giving you like the only useful thing that I know, is that people who come to me and go, my first year did not go the way I wanted it to go. And I ask them, so did you work with other people? They go, I started to, but then I fell behind and I got a little embarrassed and I stopped. I was like, okay. So basically you're playing Berkeley on the hardest possible setting, right? We want you to work with other people. We want you to talk to other people about the work. And if you try and work alone, it will be much, much harder. And all of those students who come to me and say, I had a really rough first semester, they change the way that they work, they share with other people, they're part of study groups, they do just fine. So it's going to office hours, but it's just being open, right? The goal is not to like receive an assignment and then disappear into a hole and then come out of the hole with the answers to it. You want to learn from the other students, right? They all have different ways of approaching problems. How big is the freshman BioE class? That's Pam. Do you remember?
Well, we don't know until you all complete your statement of intent to register, but we are usually shooting for, I think, maybe 120 this fall. That sound right?
Yep, that sounds right. What dorm would you recommend? Oh, that sounds like a great question for that panel that Pam mentioned. I have no idea. This is the question, I apologize, I am least suited to answer. Question about the gender and demographics. We're floating right around 50% men and women. And in terms of underrepresented demographics, pretty good, especially compared to I had this on the tip of my tongue. Pam's got it.
I would say that we are the only engineering department that has full gender parity. We run 51% female right now. So yay. There will be lots of opportunities for women in leadership roles and lots of opportunities for men in leadership roles. We're very non-gendered. And we are about engineering average in our ethnic diversity, which is, there's room for improvement, but we are also working very hard on that right now. So it is improving every year.
Yeah, our recruitment in that area stepped up significantly around 6 years ago, and that is continuing to affect the demographics of the department in a positive way. How are classes typically structured? How much do students speak in class? Totally depends, right? You will see classes are run the best way that faculty member knows to run that particular class. So there are classes that are very active. There are classes where you do a lot of group work and then report back in a larger class. There are classes in active learning classrooms. So how much do students speak in class? I think it's a wide variance, but it is not at all uncommon. In fact, I would say it's the norm to have classrooms that are active rather than passive.
Terry, explain to us why undergrad research is so important and what people get out of it.
Okay. So undergraduate research. First off, it is where you learn to fail. You are going to go into undergraduate research and things are not going to work, and it's going to feel weird because that's not how classes have probably worked for most of you most of the time. It is transitioning from a process where you're taking classes, and in classes, I'm going to let the cat out of the bag here. I'm not surprised by any of your answers. I know what the truth is, right? Like I've got the answer. It's in my back pocket. The goal is for you to learn how to reiterate previously solved problems that are necessary to understand things. Research is where you do and discover and build things that have never been built or discovered before. You are doing completely original work in a lab. And that means that you will fail sometimes. And please continue to fail. Because if you go out into the world and you go, I'm an engineer and everything that I do works, I'd be like, wow, you must work on boring stuff. I want you to work on stuff that fails sometimes. I want you to be ambitious enough that you are doing really interesting, risky things, but you're wise enough and you know enough engineering that you get out of them quick. Like, this isn't working, I'm going to go to the next project. This isn't working, I'm going to go to the next project. So research is the first time where you do that. It's also where you start to develop a taste for unsolved problems. What problems are important? What problems are tractable, meaning that you can do something about them? What problems align well with my skill set? These are really valuable things that are difficult to learn outside of a genuine experience. Is it common for BioE students to do research shadowing or volunteer at UCSF? Yes. How does the commute there work? It works. I mean, there is public transport. It does take a while to get back and forth, but people will often sort of arrange their schedules to have a day or two a week where they're UCSF based, and then take the rest of their Berkeley classes on another day. It's challenging, but it's worth it if that is your interest. Also, if you want to do stuff at a hospital, UCSF is not the only hospital in the area. Class sizes for different classes. Big initially, getting to small, the 30 to 50 in the senior year, sophomore, junior, slightly under 100. Freshman year, a lot of big courses, but you'll have small, 25, 30 person discussion sections. How big of a role does grade deflation play in bioengineering? Grade deflation? Okay, so grade deflation. So deflation would be like grade inflation is everybody getting higher grades, and grade deflation is people getting, lower grades. This is something that I think everybody on the Berkeley campus is really working on, but our goal is that you get a grade that you deserve based on the work that you did in the class. It's not that it's based on, this is the material I want you to learn, have you learned it? It's not based on, have you done half a point better than someone else in the class? So for example, Gen Chemistry is a good example of this. They basically publish at the beginning of the class, there's this many points in the class. If you get this many points, you get this grade. If you get this many points, you get this grade. I do something similar in BioE 10. In BioE 104, I may move to a system like that, where if everybody does fantastic, everybody gets an A, right? And if nobody does fantastic, people get a bunch of Bs, right? It's fine. But there is no sort of pressure to create a distribution of grades where one doesn't exist, if that makes sense. How are grades curved? It depends on class to class, but like I said, in BioE, we don't have a culture of a strict curve. So a curve can mean a variety of things. A strict curve is no matter how well you do, 10% of you get Ds, 20% of you get Cs, 40% of you get Bs. And we just typically do not do that in BioE. We may adjust the grades. So for example, we don't typically do a 90 and above is a 80 and above is a because I mean, it's not really a really good setup, because it means like 60% of the points don't really mean anything because they don't tell you anything about where you are. So we may adjust, like where the grade breaks are, and curve in that way, but we don't have the sort of strict curves where the expectation is you must give this many Ds, this many Cs, etc. Yeah, if you do the work, you pass the class. And I have, BioE 104, I'll give an example. I had one semester, I gave well over 60% A's, because that's what they earned. Like they exceeded expectations, right? And that's not a percentage I've given every semester. It's based on what they did and where the work was. Do they have a GPA requirement for research? No. There may be a GPA requirement for using one class number for research, but you can still do research regardless of the GPA. You just have to use another course code. What's the process to apply to MET plus BioE? You would want to refer to MET for that. So I would refer that to the MET office, because they're the ones that process those applications. I just realized I've been screen sharing this whole time. You're just staring at these GIFs.
We're just about out of time, so you might want to parting comments.
Oh, so which dorm would you recommend? Again, I can't really say even in terms of proximity, but that's a great question for the students. I would say, let's see. Okay, so you're trying to make a really hard decision, right? Like, what am I going to do, both with my life and my college decision, right? It's big, and I get it. And to be totally honest, many of you are probably have like a bunch of great choices, right? Here is what I will tell you, and it's a little terrifying. You'll never know whether you made the right choice. I think Berkeley's great. You probably have other choices that are also great. Fantastic, right? Your goal is to use the information that you have to make the best choice that you can at this time. And you have to make a choice, and then you work forward from there, right? And you may be worried, like, is this what I want to do? Is this what I do? This concentration, all of these things, no matter what you do, you're going to get a point of view. You're going to learn a discipline from the point of view of the department that you choose and the instructors in that department and the people that you work with, the other students that you work with. And you will take that point of view and you'll apply it to new problems. Your entire career, your entire life is going to be a process of learning new things and adjustment. It can start at Berkeley, it can start at another place. It's great. We hope at Berkeley, because we like it here and we would like you to be here. But honestly, we're glad that you're here and interested. And I would say, take some time, figure out what excites you, and then look at the classes and the research and what Berkeley does, and decide if Berkeley is the place that can prepare you to solve the kinds of problems that you want to solve. At the end of your career, you want to look back at your career and go, I fixed that. I built that. I made that less worse. I made that a little better. I helped these people. I made something less painful. I help people live longer. I made stuff that people need. I had an environmental impact. I spent my career well, and I regret a whole lot less of it than I admire. And if Berkeley is the place for you to do that, we'll see you in the fall.